Here we go. So starting section 5.2, we are just going to learn to identify one of the key attributes of a graph. Because as you graph more and more of the rational functions from the previous section, you begin to notice that those asymptotes are super important. They help you identify how the graph is behaving. It helps you identify where the graph is located on the Cartesian plane. And so when we graph things that are not in the format of one of the basic functions, like this first one, x minus 1 over x plus 4, the first step to the process is going to be to identify the asymptotes, okay, because they're that important. They're going to give us 80% of the information we need. So vertical asymptotes are where we're going to start. Where did the vertical asymptote, when we graphed the reciprocal function and the reciprocal square function in the previous section, where did the vertical asymptotes occur? When what happened? I just happen to have the sheet right here. Here's the first one we graphed. Where did the vertical asymptote occur? What was happening at the vertical asymptote when I plugged in values? Looking over here, what happened with my function that I have a vertical asymptote right there? Yes, I got undefined. Yes. So I got a 0 in the denominator. Okay, awesome. So to find vertical asymptotes, here is the process. Vertical asymptotes occur when the denominator is 0. Vertical asymptotes occur when the denominator is equal to 0. When you have values that you plug in that you would get undefined. Vertical asymptotes do not occur when the numerator is 0. So I did not talk about the numerator at all until just now. So do not worry about the numerator when you're finding your vertical asymptotes. So here goes. I'm going to do this first example. Pardon me. So I want to find the vertical asymptote because we are going to graph this. This is one of the examples we're going to carry along and do everything for this one. I think that's one of the ones we're going to graph. Let me see before I lie to you. Yes, it's going to be the first one we graph when we come back on Tuesday. So we're going to already have done the first step in graphing and finding the vertical asymptote. So what we're going to do is we're going to take that denominator, the x plus 4, and we're going to say, when is that x plus 4 equal to 0? Well, I'm hoping that everybody, even as quiet as you all are today, I'm hoping everybody could solve this. I'm going to subtract 4 from both sides and see that that happens at x equal to -4. That is the vertical asymptote. So the first step that we will do when we graph this is we will draw a dotted vertical line at the x value -4, because that tells me the graph cannot go through that value. I was pretty emphatic in the previous section and said graphs never go through vertical asymptotes. So that gives you a whole lot of information about your graph right away. All right, I'm going to give you 40 seconds for the next one. I want you to figure out the vertical asymptote of f of x is equal to x plus 2 over x minus 3. Okay, so I'm hoping what you did is you took that denominator, that x minus 3, and you said, okay, when is x minus 3 equal to 0? And again, that's a fairly relaxed linear equation. I'm going to add the 3 to both sides, and so x equal to 3. So when you go to graph that, I believe that's the second example. It is. When you go to graph that on Tuesday, the very first thing you're going to do is make a dotted vertical line at the x value 3. So congratulations, you're already one step into the process. So here's my last example for the day, because I told you earlier that rational functions can have any number of vertical asymptotes. So this one right here, we're going to do the same thing. F of x is x plus 1 over x squared minus x minus 6. So once again, I want to know the vertical asymptotes. I'm just going to look at the denominator. So what we have is a cute little quadratic equation right here. So you are welcome to solve that. The quadratic formula always works, but when we're graphing, you're not really going to end up with decimals and irrational asymptotes. That would just be mean of me. And even though you might think I'm mean, I try not to be mean. And so what we're going to do is we're going to factor this. X squared is x and x. The two factors of -6 that are going to add up to -1 are, what are they? 2 and -3. 2 times -3 gives me -6. 2 plus -3 gives me -1. So I don't know if we're graphing this one or if this is just an example, but if you were to graph this, you're going to have 2 asymptotes on this. That's going to be double the fun. The first one will be a vertical line at x equal to -2, and the second one will be a vertical line at x equal to +3. All right, you're almost to the weekend. Here's your second to last example right there. So find me the vertical asymptotes to 3x squared over x squared minus 16. So again, I'm going to take the denominator, x squared minus 16. When is that equal to 0? I'm going to factor this, but you could also add the 16 over and take the square root of both sides. We saw that that was a legitimate way to solve some quadratic equations. The two factors, well, since it's a difference of squares, the two factors are going to be +4 and -4. So you get x plus 4 equals 0, x minus 4 equals 0. And so in this case, there are 2 vertical asymptotes again. The first one is a vertical line at -4, and the second one is a vertical line at +4. All right, last but not least, find me the vertical asymptotes for the final rational function at the top. All right, so just in the interest of time, because I know I have gifts to give back to you today, so I'm going to take that denominator, I'm going to set it equal to 0. It's 24. Thank you for catching that for me. Sorry. And so now I'm going to factor that. So the two factors of -24 that add up to -5. Hopefully you wrote down -8 and +3. So that gives you 2 asymptotes. The first one happens at the x value 8. You'll put a vertical line there. The second one happens at the x value -3. You're going to put a vertical line there. And that's where we'll stop. So if you happen to feel ambitious and you start doing homework for section 5.2, you can do anything at the beginning that says find the vertical asymptotes.